Thanks a lot for the introduction, Matthew. Thank you everyone for attending. My name is Iosif Itkin. I'm CEO and co-founder of Exactpro. We are a software testing business focused on functional and non-functional testing for mission-critical market infrastructures. Most of our clients are regulated by Bank of England, FCA, and their counterparts in other countries. We were part of the London Stock Exchange group for 2.5 years. We bought the company back earlier last January 2018. The company currently employs over 500 specialists. We have clients in 23 countries, mostly across exchanges, clearing, depository areas. We have multiple partners focused on financial services and software quality. We're actually planning to have 3 different conferences today, but 2 of them were canceled and only Cave Financial went forward. So thanks a lot for attending, thanks a lot for supporting the event. I would like to quickly touch on 2 of the initiatives. There is fixed trading community MOST group called Monitoring, Onboarding, and Software Testing. It is focused on developing best practices for fix and other trading protocols. Please do join if you're working in this area. And another one is called Zero Outage. It is an initiative focused on platforms, people, processes, and security to achieve less outages in various industries. So the industry standard, Zero Outage industry standard, involves multiple technology vendors, and they are very open to accept more members, and there are quite a lot of work to achieve this goal. So a year ago, we supplied several quotes to the press about blockchain readiness for production usage. And one of the articles stated that blockchain financial plumbing still years away, and to a degree, it is still an open question. But there were several main reasons why we've considered that blockchain systems are quite far from production usage. And the main one is that a year ago, most of the projects that we saw were in proof of concept area rather than software testing. There is a substantial difference between software testing and proof of concept. Proof of concept is when you're trying to prove that something works. Software testing is the opposite. It is when you're trying to prove that something doesn't work. And it is the same difference like between journalism and activism. So you are not trying to change the world to the better activism, but you are trying to find the truth. It is the true journalism. There are many relations between true software testing and true journalism. But in a complex systems, in complex societies, it is very important to know the truth. And most of the projects that we saw a year ago, they were mostly focused to prove that something works, not software testing. The same situation we observe now with chatbots. We are actually struggling to find any project where software testing will be required for a conversational assistant, because in most of the cases, people either already know that they do not work, or they do not want to discover it. So there are 2 funny examples. One is well known, is the Microsoft Taybot that was shut down, and people consider it to be a public relation disaster. Personally, I think it is a substantial research breakthrough I would rather prefer to test a racist Twitter bot in production comparing to racist self-driving car or medical device. So, and wherever we look, we see that no one really interested to put the chatbot for the test, another one. So even at the top level, there are limitations of finding it. And the same situation was with the blockchains a year ago. Eventually, I'm very happy and very proud that we were able to find an infrastructure ready to research what's going on and to try to find the truth about how it operates. It is a R3 Corda platform available both in open source and enterprise version. The idea is that in financial services today there are quite a lot of duplication, high fragmentation, and expensive reconciliation. So different people think different things about the data that they have, and there is no ability to proceed without expensive reconciliations. Maybe not everyone knows that, for example, two of the most famous financial services outages, both happened in 2012, can be attributed to reconciliation process. In ideal world of tomorrow, there will be a shared ledger and a shared ability to understand what's going on. It will result in reduced cost, reduced operational risks, and no inter-entity reconciliations. But in traditional blockchains that are available, public blockchains, when somebody knows about transaction, everyone else knows about transaction, and it is not really applicable for financial services. So there is no privacy. There are other more enterprise-focused blockchains, but they currently split the data into channels, so everyone knows about everything within the channels, but not across the channels. Enterprise Corda, or open source Corda, introduces a completely new approach to dealing with data. It allows to split all the facts on a fact-by-fact basis, so only those who need to know will know about them, and still there is consistency across a distributed network. So Corda is essentially enterprise-grade ready blockchain platform. It would be fair to say that our greatest weaknesses also come from as an extension of our strengths. So of course, even with Corda, as you split information on fact-by-fact basis, it means that if particular part of the network is not aware about substantial set of the facts, and then it is connected, there will be a substantial delay for transferring this information that was not previously available. And there are other things. Of course, distributed platforms will never be able to do the same things that we do in exchange world, in centralized exchange world, where we have microsecond latencies. Still, so unfortunately, my colleague Murray was not able to join today, but you can always go to YouTube channel and there is presentation from R3 describing software testing challenges for R3 platform called Testing in the Fast Chain. So Corda is enterprise-grade blockchain platform enabling distributed parties to form and maintain consensus about specific facts in very efficient manner. It contains multiple key concepts, but one of the main of them is Corda node. It is a part of the system that encapsulates all the processes related to data interactions between various parts of the network. There are also things responsible for maintaining the network as a whole and also for preventing double spending, such as notaries for preventing double spending and network map, so various entities can identify each other on the network. So Corda is a permissioned network rather than permissionless network. One of the major challenges that we encounter while testing for the Corda network is its extremely heterogeneous network. It is possible to deploy different versions of the network, different versions of applications on different security devices, different databases, different Java machines, operating systems, everything. So essentially, it creates a combinatorial explosion when you're trying to work with it. And there are many other specific challenges, like the system is, of course, highly distributed. It requires security. It needs to be eventually consistent, so it becomes consistent after some delay. It always evolves because there are upgrades to nodes, to applications, to the network itself. It needs to be highly available. Once again, notary clusters are responsible for assuring there is no double spend. It needs to be highly resilient. And of course, everyone expects that financial plumbing of the future will be performant, so it is necessary to do quite sophisticated performance tests. In blockchain world, in the Corda world, it is more than in some other places obvious that there are parts interconnected between each other, and you can use one part of the system to test another part of the system. In particular, in this case, it is possible to use distributed applications to test the core network, and it is also possible to test the core network, to use core network in order to stress particular distributed applications. So it is like yin and yang between test tool and the system under test. What is also interesting is that in decentralized environment, you immediately encounter the fact that everything is multi-threaded and distributed. Another funny fact, so there is now a new certification exam and people are looking into it, called AI and software testing. And one of the key features of the AI systems, what makes them testing for them challenging, is their non-deterministic nature. And that's why there need to be special tools, methods, etc. But if we look at financial market infrastructures, in post-trading financial market infrastructures, at highly complex, distributed, highly loaded systems, we will see that they were always non-deterministic. And in order to test them properly, the same tools and methods will require special tools. So the same challenges that we now encounter when we work with AI systems, they were present for years in non-deterministic large-scale platforms. In order to test such systems, direct methods are not enough. It is also necessary to use indirect testing methods such as passive testing, post-transactional verification, etc. And ability to deploy agents that will be able to do this work is the scope of end-to-end testing for distributed platforms, for AI platforms, for everything. There is a model called Pierce model that describes what is required from the agent, and it consists of 4 parts. The first part is environment. Environment, it is where our agent or test agent operates, And for us, it is essentially a system under test. The test agent environment for the test agent is the system under test. Actuators are tools that enable to do something with the environment, so to do active testing. Sensors are the tools capable of obtaining information from the system to get the knowledge. And performance is something that will give us understanding whether we are moving closer to our goal or not. For example, it can be a set of rules, set of checks, tests, etc. So what we've discovered in testing the systems like Corda and other post-trade massive infrastructures, when looking at actuators, the most important thing is that they should not be a perfect software. Rather, you need to ensure a diversity of software in the actuators. So instead of having a single perfect test tool or single perfect active test approach, it is necessary to have different, even poorly written software components in order to cause harm to the system. So you are not creating, when you test software, you are not looking into the way to ideally connect to it, but you are looking into diverse set of methods that will cause most of the disruption. For testing on the sensors part, what we've discovered is that it is very important to keep sensors independent from the actuators. As soon as you merge a sensor and the actuator, they start to affect each other, and none of them works in optimal ways. So it is very important to separate the active testing part from the passive testing part when you test such systems. There is quite a lively debate going on currently in the internet in relation to HTQB recent paper called The Vision of Software Testing, the vision on the future of software testing, and whether it is possible to replace the performance part from the rule-based into something more intelligent. But even when we will replace the rule parts with the more intelligent approaches to address what I've mentioned for heterogeneous networks, combinatorial explosion of the combinations and other things, there's still the question of how to interact between such tools and QA analysts. So essentially, there is a difference. So the test tool has two parts. One is looking towards the system under test, for example, Corda network or post-trade system, and another is looking towards QA analysts. And there are the opposite requirements between two parts. For the part that looking at the system under test, it is necessary to achieve maximum diversity and disruption. For the part that is looking towards QA team, you need to have uniformity and usability, so it is easy to control what's going on. So we need to torture systems, we need to keep people safe, especially software testers. In order to achieve it, it is necessary to collect most information that comes through the sensors and store it into the data lake. When the data is stored into the data lake, it is possible to use it both to control the software testing and also to apply different methods. As I mentioned, in complex distributed systems, they are frequently non-deterministic, and they do have oracle problems. It is when it is not easy to immediately say what is okay and what is not okay. So having ability to store the data for processing in the data lake allows us to apply additional software testing methods such as metamorphic testing. Metamorphic testing is based on assumption that when something changes, so for example, network evolves or particular component, we are not able to predict what it will reply at every given moment in time, but we still can identify the relations between parts of the system, between different inputs and outputs that should remain constant. For example, it is not easy to predict, well, it is easy to predict what sinus function will produce, but it is quite a challenging calculation, and you need to basically replicate the same thing in order to measure it. Or if you have a risk management system that calculates complex structured products, pricing for complex structured products, in order to validate the whole model, you might need to replicate it as a whole. Metamorphic testing is when you find relations that remain constant. For example, that when you have, say, a large system and there are many trades going out from it for derivatives, where there are both outrights and butterflies, spreads, etc., and then K mix between each other in all possible ways. But what you know is that amount on the buy side should in total match amount on the sell side for every meta trade. So you can do validation and check metamorphic test, do a metamorphic test regardless of what was input into the system. So when we work with non-deterministic distributed systems, we need to look for these metamorphic relations and try to check that they remain in place. And in order to do it, we of course need to collect the data in order to use it to identify such things. So this is essentially how we are building, along with our partners, the software testing tools to test something that is distributed, complex, and that will be very useful for the future of financial services. So please do subscribe to YouTube channel. It contains quite a lot of information, and I will gladly answer questions if there are any. Thank you.
Well, would you mind turning on my mic, please? Thank you. Yeah, I have a question to start. Iosif, thank you for the presentation. Presumably, you've talked about the complexities of testing the systems. Presumably, the opportunity in the creation of new distributed ledgers and new smart contracts is to build them in such a way that they facilitate automated testing. Can you give us some insight into how that might work and how you've worked, for example, with Corda in the actual design of the platform to increase the efficiency of delivery and change?
Well, so once again, it is a funny thing that production usage of the system and test usage of the system, they have different objectives. Production usage is to work in a very narrow set of scenarios to prove that this, well, not to prove, but to ensure that the system operates in the most useful and efficient way. In testing, we need to have a substantially broader set of scenarios, and in order to cause them, we should not develop the most efficient smart contracts or distributed applications in Corda, but instead we need to try to do as many stupid things as possible in many distributed applications. This way we can cause additional problems to the Corda network itself and also to other distributed applications. So, and it is a problem in good engineering companies that have very strong development teams because they are looking into creating very good software. And when you're creating something for production, it is a good objective. When you're creating something to test, you apply like not pesticide effect, but you are trying to remove any interaction with like with bacteria or viruses. If you are not encountering them for quite some time, you start to lose your immune system, and it is very important for these complex systems to have immune system. And in decentralized environment, the best way to have immune system is to have quite a lot of things that can constantly produce defects and problems.
Thank you. Does anybody else have a question for Iosif? In which case, thank you very much indeed.
Thank you. Thank you very much.